Hey everyone, welcome to this explainer. I'm super excited you're here. Today, we're going to act like your friendly neighborhood tutor and totally demystify a massive topic in computer science, object-oriented programming, or OOP. Now, if you've ever felt completely overwhelmed by all the jargon, don't sweat it. We're keeping the English super clear and simple today, and we're zeroing in directly on the essential keywords you absolutely need to master this concept.
All right, here's our quick roadmap for today. We'll start with the early coding nightmare, move on to the rise of structured programming, and then check out the object-oriented solution. After that, we'll explain objects and classes, dive into the core pillars of OOP, and finally wrap up with the awesome power of reusability.
So let's kick things off with Section 1, the early coding nightmare, and exactly why those old languages failed. Okay, let's jump right in with a super direct question. Why do we even need object-oriented programming in the first place? I mean, what was the actual real-world problem it was invented to solve?
Well, back in the early days, writing code was honestly like dealing with a giant tangled bowl of noodles. A total programmer's nightmare. There were zero facilities to reuse existing code, none. If you needed a block of code again, you literally had to copy and paste it. Plus, programmers heavily relied on these dangerous go-to statements that made the program jump around so wildly, it was basically impossible to read. And the absolute worst part? Variables were global. Imagine trying to track down a random accidental change in global data across a massive program. Just an incredibly tedious, pull-your-hair-out kind of job.
Moving on to Section 2, the rise of structured programming and breaking things down.
So, in the late 60s and early 70s, a huge breakthrough happened, bringing us to a very crucial key word, functional abstraction. This basically permitted a programmer to look at a block of code without stressing over its internal nitty-gritty details. By chopping long programs into smaller, manageable functions, you could just focus on the specific task being performed. And crucially, these functions had local variables, which finally put an end to that whole global variable nightmare we just talked about.
But, structured programming wasn't totally perfect. Notice the stark contrast here. Structured programming puts all its emphasis on doing things, the functions, and unfortunately treats data like a second-class citizen. Because of this, it really struggles to model real-world concepts, like GUI menus or windows. Object-oriented programming, on the other hand, flips the script entirely. By putting the data first, the code actually matches the real world.
Which brings us to Section 3, the object-oriented solution and putting data first.
The fundamental shift in OOP is safely combining data and its operating functions into a single secure unit, an object. You absolutely cannot access the data directly from the outside. You have to go through the member functions. This brings us to a massive keyword, encapsulation. It keeps your data completely safe from accidental alteration and makes debugging so much simpler. It's like putting your data inside a bank vault. Building right on that, we hit another critical keyword, data abstraction. Just like functional abstraction hid the messy details of operations, data abstraction hides the exact details of how things are implemented in binary. For instance, you don't really need to know how a floating point number is represented in binary just to use it, right? OOP takes this a step further, letting programmers define their very own, complex, abstract data types.
Next up is Section 4, Objects and Classes Explained. These are your foundational building blocks.
So the most crucial thing here is really understanding the difference between a class and an object. Let's tackle the class first. A class is simply a blueprint or template. It's a user-defined data type that specifies exactly what data and what functions will be included. So if you create a template for a date, you've just made a class. But remember, just defining a class doesn't actually create any variables or take up any memory yet. It's purely just the blueprint.
But once you have that blueprint, you can finally build the house. And in programming, those houses are the objects. They're the actual realized versions of our classes. Think about some great candidates for this. You could model employees in a payroll system, data structures like stacks and queues, GUI menus, or even the cannons and guns in your favorite video game. Objects basically let us model real-world things directly inside our code.
All right, moving into Section 5, the core pillars of OOP. Listen up, because if you've got an exam or a job interview coming up, these are the heavy-hitting keywords you absolutely must know. The first major pillar is inheritance, and it's exactly what it sounds like. It's a concept where new classes, which we call derived classes, can be built straight from existing old ones, which are the base classes. The new class just inherits the data and functions of the original. This means you get to add cool new features while safely holding on to all the old ones.
Think about how we build hierarchies in the real world. Let's say we have a base class called publication, and it has basic things like a title and a publisher name. From there, we can branch off into two derived classes, like a periodical and a book. A periodical inherits the title, but maybe adds an issue number. A book inherits that same title, but adds an ISBN number. They share those basic traits from the parent, but have their own unique attributes.
The next totally essential keyword is polymorphism. Poly means many, and morph means forms, so it's the ability of one thing to take on several distinct forms. Going back to our books and periodicals, physically retrieving a periodical from a binder is a very different action than pulling a book off a wooden shelf. But polymorphism allows us to use the exact same function name, like retrieve, and the program will magically know how to act differently depending on which specific object it's interacting with. It's pretty brilliant.
And finally, Section 6, the power of reusability, where you save time and write much better code.
We've learned all these amazing keywords today, but the ultimate payoff for all of this is reusability. Object-oriented programs are built using reusable software components. Once a class is completely written and fully tested, you can just distribute it to other programmers. If they want to add new capabilities, they don't have to rewrite your existing code, and they don't risk breaking it either. They just use inheritance to derive a brand new class. This saves an unbelievable amount of time and perfectly isolates any programming errors.
I want to leave you with this really powerful thought from our source material. The world is, therefore, object-oriented, and the object-oriented programming paradigm expresses computer programs in ways that model how people perceive the world. Mastering OOP isn't just about learning syntax to pass a test. It's a fundamental shift in how you think. You're literally learning how to translate the objects of the real world directly into your software. So, I gotta ask, if the entire world is truly object-oriented, what real-world object are you going to try to model in your code first?